In the second part of Mod 7, we're going to look at the ambiguous case for the law of sines. We can use the law of sines for side-side angle when you know two sides and then an angle. However, there may be no solutions, one solution, or two solutions. Because we don't always know how many solutions there are going to be when we are doing side-side angle, this is called the ambiguous case for the law of sines. When you are applying the law of sines in the ambiguous case, if you get sine of b greater than 1, remember the sine cannot be greater than 1. The sine has to be some number between 0 and 1. So if you get greater than 1, there's no solution. If you get the sine of b equals 1, well then there's one solution and your angle B is 90 degrees. If you get the sine of angle B equaling some number between 0 and 1, then there may be either one triangle or two triangles. If you think back to the unit circle, we talked about that the sine will be positive in the first and second quadrants because the y is positive there. In the second quadrant, the angles are between 90 and 180 degrees. We can have angles like that in a triangle. So, in the ambiguous case, if you have two triangles, we can have one acute triangle and one obtuse triangle where there is an angle between 90 and 180 degrees in the triangle. In our first example for the ambiguous case, we are told to consider triangle ABC with side C equaling 45, side A equaling 55, and angle C equaling 25 degrees. Solve the triangle. We are told to carry out intermediate computations to at least 4 decimal places and round the final answer to the 10th. When you look at our given information, we do have the pair of side C and angle C. And then we are given side A. So what this is going to require for us is that we must try to find angle A first because of the pairings that we have. So our side C of 45 goes over the sine of angle C, which is 25, and that has to equal side A of 55 over the sine of angle A, which we don't know. We are still going to solve by doing cross multiplication. In this case, we will have 45 times the sine of angle A equals 55 times the sine of 25. Our variable is here, it's angle A, so we need to get that by itself. We're going to divide both sides by 45, so we have the sine of angle A equals 55 times the sine of 25 over 45. If you do that calculation, you get the sine of angle A equals 0.5165333431. I like to go out as many characters as the calculator shows me to be as accurate as possible. So now we need to figure out what A equals. Well, that means we need to do an inverse. So A equals the sine inverse of this big long decimal that we just came up with. On your calculator, you have a key right above your sine function. There's a key that has the sine to the -1 power in it. So you can put that in your calculator, and in so doing, you should get 31.1, rounded to the 10th as our directions say. So that is our first possibility. So what I do, because it's my first possibility, is I call it A sub 1. This is the first triangle that we could have. What we're going to do later is see, do we also have a second triangle? So now we know angle A, angle C. What we don't know is angle B. And since this is for our first triangle, I'm going to call it B sub 1. Take 180 minus the 25 we were given, minus the 31.1 that we just figured out, and angle B would have to be 123.9 degrees. So now if you think about, we just found A and B for our angles. So we do know all three angles. We were already given two sides, so what we don't know as yet is side B. We can do the law of sines now to find side B because we know angle B. So we are going back to our given pair of 45 over the sine of 25 equals side B, the last thing we need to find for triangle 1. So I'm going to call this side B1 over the sine of angle B sub 1, which is 123.9. Cross multiply, you're going to have B times the sine of 25 equals 45 times the sine of 123.9. Divide by the sine of 25, so B equals 45 times the sine of 123.9 divided by the sine of 25. So we get a side B sub 1 of 88.4, rounding to the 10th. So there's our first triangle. To figure out whether or not you have a second triangle that's even possible, we have to think about what's going on here. Let me explain a little bit about what's happening here. Our first angle that we found was 31.1 degrees. That's the first quadrant angle. We need to find the second quadrant angle, the obtuse angle that would be possible in the triangle. It may or may not exist, so we have to see if it does exist. So what we're going to do is set up a reference angle in the second quadrant that is also 31.1. So what we need to know is, what is this angle measure from 0 over there? Well, how do we find that? That goes back to old work that we've done. We have to take that away from 180. So our A2, our possible A2 is to take 180 minus the 31.1 that we found for A sub 1. If we do that, we get 148.9. So our obtuse possibility is the 148.9. Now we were given angle C and we have an angle A. We have to see what angle B would be. So B sub 2, now we're using the 180 for the measures of the angle of a triangle. So we're going to take 180 minus angle A, which we just said is 148.9, minus angle C, which we were given is 25. If you do that subtraction, you do have an answer of 6.1 degrees. So what that tells me is, yes, I do have a second angle in this ambiguous case. Now we know angle A sub 2, which we didn't know. We know angle B sub 2, which we didn't know. The thing that we are still missing is side B sub 2. So we're going back to our given information of 45 over the sine of 25, our given pair, equals B2 over the sine of the angle B2, which we just said was 6.1 degrees. Cross multiply, you're going to have B2 times the sine of 25 equals 45 times the sine of 6.1. Divide, so you get B2 equals 45 times the sine of 6.1 divided by the sine of 25. So the second side B is 11.3. For our second example on the ambiguous case, we have triangle ABC with side B of 53, side A of 60, and angle B of 39 degrees. So notice on your ambiguous case problems that you are given two sides and one angle. On the cases that are not ambiguous, you have two angles and one side. That's how you're going to tell the difference between them. So looking at this one, our pair is 4B. So we're going to set up our law of sines for B with a side B of 53 over the sine of angle B, which is 39. Our other relationship has to use A because that's the side we're given. So we're going to put our side A of 60 over the sine of angle A. Cross multiply, we're going to have the sine of angle A times 53 equals 60 times the sine of 39. Again, notice that your variable is in with the sine, so we need to get the sine function by itself. Divide by 53. You're going to have the sine of A equals 60 times the sine of 39 over 53. You will then get that the sine of A equals 0.712438179. To find what A equals, you have to do the inverse sign of that big long decimal. And this should give you an angle A of 45.4. This is our first possibility for A, so this will be A1. So now we know angle B and angle A1. We're going to find angle C1. Do 180 minus angle A, which you just found to be 45.4, minus angle B, which we were told is 39. So angle C must be 95.6. We are still missing side C for this triangle. So go back to your given pair of 53 over the sine of 39 equals side C 1 over the sine of 95.6, which we just said is angle C1. Cross multiply, you get side C1 times the sine of 39 equals 53 times the sine of 95.6. Divide. We get C1 equals 53 times the sine of 95.6 divided by the sine of 39. So side C1 is 83.8. Now we know all the parts of our first possible triangle. We have to see if there is a second possible triangle. So the first angle that we found, the A1, was 45.4 degrees. That's a quadrant 1 angle. So if we put an angle in quadrant 2 that's a reference angle of 45.4, what's this angle? That's our second possibility for A. So our A2 is 180 minus 45.4, which gives us 134.6. To find our second C2, we're going to use the fact that the sum of the angles of a triangle is 180 and take 180 minus the 134.6 that we just found minus the 39 that we were given. So our second possibility for C is 6.4 degrees. Now that we know all three of our angles, we need to find the missing side, which is side C2. We'll go back to our given pair of 53 over the sine of 39, and this has to equal side C2 over the sine of 6.4. Cross multiply, you get side C2 times the sine of 39 equals 53 times the sine of 6.4. Divide, you get C2 equals 53 times the sine of 6.4 divided by the sine of 39. So side C2 must be 9.4. Son of a bitch.